So for the predicting the stock market using machine learning project that we did for ENGI 420, we'll go over the starting phase, the inputs, outputs, and the first phase of GenPy, and Joey will have the second phase of the project. So a little overview, we'll have a project description, the features and inputs we use, the ANOVA of our features, the targets and outputs of our project. The types of machine learning that we used, we used several types to compare, and then conclusions and further research. So a little bit of description. We wanted to predict the direction of the stock market. It's not an easy task because it's highly volatile and variable. But we chose a stock indice, which is the S&P 500, and it's a collection of 500 U.S. stocks that come together to form one stock price. And we wanted to basically see if we could find features or input variables that could help predict the stock price, whether it went up or down in a given day, to help inform if you should buy or sell stock or stay at the same level. And we also wanted to see if predicting weekly as opposed to daily would be more effective, and so we will compare them both. So I'll start out with the features / inputs that we used. And so first we started out, we went through several iterations in information gain to get a final optimal or useful prediction. So first we just started out and used like 3 or 4 of these foreign stock indices, which would be similar to the S&P 500. And we chose the foreign ones because their stock market would end or would close before the U.S. stock market opened on the same day. So you would know their close price, whether they went up or down, and various information about them. It was somewhat accurate, about 50%, so it wasn't great. So then we decided, well, what if we added in valuable American stocks like Microsoft and Amazon and Facebook and etc. And then we also picked up some economic rates and prices such as the oil and gold price, and also U.S. Dollar exchange rates in the U.S. and other countries around the world, and then also for plus or minus for a several period of years, whether the dollar went up or down. And then finally, we did some lags on the S&P 500 of 1, 2, and 3 days. And all this data was taken from 10/1/2015 to 10/1/2019, so 4 years worth of data. And here's a sample of what some of the data looked like. All in all, I think we had 27 features. And this is just a small sample. Someone did some ANOVA of the features. And as you can see, only a few variables were actually significant for weekly and daily. However, all of the variables working together would give a good R-squared value, showing a good correlation and a fairly low mean squared error. And then also the model itself was significant. As you can see, a low F score or high F score. And that means that the overall variables do not affect the output that much. So next I'll go over the targets and the outputs that we used. And so basically we would predict up or down for the S&P 500 for daily and for weekly. And as you see, the binary variable is just a 0 or 1 for up, 0 for down, and 1 for up. And then also we thought future and possibility of predicting the amount that it went up or down. And this could give a future resource levels to determine how much you should buy or sell based on how much it was predicted to go up or down. And that could be more accurate. And then also these output data were taken from the same time ranges before. And so now I'll pass it over to Joey and he'll go over the models we used.
The articles used in our references helped us to really formulate our data and find the best features to use in this model. For the weekly model, we had found that the features of using the S&P's price 1, 2, or 3 lags back in days, and the difference of change in volume of the number of stocks had made the model worse for weekly. So we had removed those. Once we had done that, we used a neural network, a fitting neural network for this. And as we ran it through, we used 1,462 samples. 70% of that was for training data, 15% was testing, and 15% was validation. We chose to use 10 hidden neurons. And as you can see from the results, we had pretty good R-squared values showing good correlation between our inputs and outputs. However, the mean square error is quite high for these. If you look down here at the error histogram, it's showing a pretty normal distribution, which is a good sign. Means the errors are random, which is an indicator of an accurate model. So now coming over the daily data, we actually used those in our data. We used the lags of 1, 2, and 3 days back in addition to the volume of stocks, because it actually helped in the daily data. And as you can see, slightly better R-squared values showing good correlation, and actually slightly lower mean squared errors. And once again, the error histogram is showing a normal distribution. Next, we also used a support vector machine. And we ran through the data through this as well for predicting the stock market a week in advance versus a day in advance. And from the weekly data, we can see the SVMs did pretty well. The cubic SVM actually did best overall for both models. But actually this time, the weekly model did better with an 86.3% accuracy. And looking further into the true positive rates, we can see 87% for here, which means that the model predicted a 1 correctly, meaning the stock market would go up 87% of the time. And over here, we can see that the model predicted a 0, or the stock market went down 85% of the time, which is very accurate. Now we come over here to the daily SVM. Once again, as I said, the cubic SVM did best. And each of these different types of SVMs just have different kernel functions that are taking the input data and transforming it into their required form. Many of these kernel functions include linear, nonlinear, polynomial, the radial basis function, sigmoid functions, stuff like that. And so if you see down here, this one did 83%, which is good, true positive rate for predicting down in the stock market, but only 49% for predicting an up. So as you can see, this model did not do as well as our neural network did. Next, we have a decision tree methodology. And for the weekly data, we can see that the ensemble of bagged trees, so an ensemble of trees would be random forest, would be 88.2%, which is fairly good. 91% for predicting a up in the stock market when it went up, and 83% predicting down in the stock market when it went down. Now with the daily data, the decision trees did not do as well, and we have many different types of trees that we tried here within MATLAB's classification learner. And the best of all of these was the ensemble of boosted trees. But as you can see, even still, it only had 52% true positive rates, which is not great. So if we come down, and now I decided to do some further analysis on the neural network for each of the daily one and then the weekly neural network, and how it actually compared to the actual price. So for the daily price, here's the actual prices listed here, and the daily prices as predicted when ran through the neural network function that MATLAB gave us after we used it. And as you can see, the percent error is pretty low as far as like what these errors are. However, the difference in price is quite significant. As you can see, only $3.86 here, but this could make a big difference as far as $30 $20 $30 if this model would want to be practically used for making financial gain on the market. And with the weekly neural network as well, you can see that there was still a small percent error in the difference between the actual price and the weekly neural network prediction, but the difference is still quite significant. Therefore, this model would need to be improved quite a bit in order to get it to a state where it could be used for financial gain, since on the stock market, prices don't always go up by quite a few dollars. Many times it's only a few dollars or just cents. So in conclusion, the model for predicting the S&P 500 index is more accurate for predicting a week in advance as opposed to the daily change up or down. However, the daily model, I believe, would be more practical, since the stock market can be so unpredictable, and there's many factors and changes that can occur that can throw off the model. We tried many different features, combinations of features. However, more research might provide better features for this data. We had even tried additional foreign stock indices because many of these would end before the S&P 500 index, which is in the US, would open. But it did not prove as effective. And we tried different combinations of different features. Deep learning could also be used with a set of rules to determine when to buy or sell shares of stock to make a profit. Once this model is improved, that would be the next step. And then based on that, there'd be some assumptions that the model would have, such as the total capital available, making sure trades are made with the closing price each day. There might be a flat rate on cost for trades. Some sources say like $8 for how much for a trade of multiple stocks. And of course, the model would need the money spent on that trade fee should not be taken from the stock's profit, but rather a separate source, so that you were accurately predicting how much the stock market is making. So from this whole process, we learned many things. Probably the most important is just collecting, formatting, and using large amounts of data from a long period of time and many variables can be very difficult. You want to make sure that the data is accurate and that you are properly representing data from that time. And that was probably the most difficult part of this project, was getting all these variables on the right timeline, removing the errors and the nulls, and making it work. We used both SassJump and MATLAB to perform much of our analysis for just this project. So thank you. These are our sources. The top two articles were both published in research journals. The first is International Journal of Advanced Research in Artificial Intelligence, and the second is the Journal of Industrial Engineering. So, and all of our data sources are down here as well. So overall, a good project. There's much improvements to be made, but there's definitely a lot that we learned from this. Thank you.